Some smart people leave others completely baffled. When they talk, it's as though they're speaking another language. You have no doubt they're very clever, but what on earth do they mean? Feynman wasn't one of those people. For him, being able to teach others wasn't some nice side effect of his own understanding. He saw his ability to clearly articulate what he knew to be instrumental in him knowing it. Many people assume that if something is very smart and important, only a few people will be able to understand it. Feynman turned this on its head. Anyone can understand anything if it's pitched at the right level, and if you can't explain it so they understand, it's not because the material's too complex. It's because you don't have a thorough enough grasp on it. Let's take a look at the IRADE method, which is a multi-pronged approach used in physics education. It was inspired in part by Feynman's words. The best way to teach is to be very chaotic in the sense that you use every possible way of doing it. Imagine the concept you're trying to teach is revealed to the student in separate snapshots. The greater the number of snapshots, and from the greatest number of different angles, the more fully they can see the concept. I is for introduce. Use narrative and story to begin. Give some context and explain why you're learning the concept and how your particular learning fits into the bigger scheme. How might it connect to what you already know? And how does it help you achieve what you're trying to achieve? If you're a good teacher, you can use story, humor, and emotion to pique interest and make the concept seem relevant. Feynman himself was famous for getting even science phobes to admit, that does sound pretty fascinating, now that you mention it. You can also begin with the dictionary definition of the terms you'll be using to get acquainted with the topic and find your footing. R is for relate. Next, show what the concept is by giving real-world examples. Give at least 3 if you can. If you start abstract and end abstract, it's difficult for anyone to see how it connects to the real world in any way, especially when it comes to physics, but also with other more abstract topics. You need to stay grounded in why the concept matters at all. A is for apply. There is, hopefully, some practical application to what you're learning about. The method or idea or theory is a tool. What things does it help you achieve out there in the world? If it's a mathematical formula, show how this tool can be used to literally work your way through some problems. You might like to connect the examples you gave to classical problems and then show how the new knowledge solves those problems. Again, you're embedding this new knowledge in a pragmatic way. Accept questions and get the students to try their hand too. Work through a range of practical applications, from easy to difficult, so that the students see the principle in action rather than just hear you talk about it. D is for demonstrate. This is connected to the earlier point. Visual demonstrations can be really powerful. Students always remember the cool, hands-on experiments in class over the dry and dull lessons from textbooks. As with writing, show, don't tell. You could recreate a mini experiment or set up a demonstration that shows the principle at work. A picture paints 1,000 words. A real-life demonstration paints 1,000 pictures. E is for examine. You want to test that what you've transmitted has been received. It doesn't have to be a formal exam or even a pop quiz. Just make sure that you're giving the student the opportunity to reflect on what they've learned. Keeping the protege effect in mind, ask them to teach back to you what you've just taught them. Then, listen carefully. The places they struggle with or get confused are the areas you need to revisit. The questions students ask you can also reveal a lot about how much they've absorbed. Get them to paraphrase, make summaries, or debate the concept to show they understand the underlying themes. Or, more classically, give them a problem of the type you've covered in the examples and demonstrations and see if they know what to do. To make sure they really understand, however, don't just rely on them regurgitating the right words. One great way to test comprehension is to show them a problem solved incorrectly or a wrong answer. Get them to tell you why it's wrong. This has been Richard Feynman's Mental Models: How to Think, Learn, and Problem Solve Like a Nobel Prize-Winning Polymath, written by Peter Hollins, narrated by Russell Newton. Copyright 2023 by Peter Hollins. Production copyright by Peter Hollins.